In this video, we are going to solve an example based on the power series expansion method. So the question is simple and straightforward. We have been given with the value of x of z, which is given as 1 divided by 1 minus 1.5 z to the power minus 1 plus 0.5 z to the power minus 2. Now the ROC is given to us as mod of z greater than 1. The question is find the value of x of n for n is equal to 0, 1. That is just 3 samples. So how do we proceed? First and the foremost thing is we will make use of the power series expansion method, because x of z is not a ratio of polynomials, because in the numerator there is a constant number and in the denominator there is a polynomial in z. So in such cases we are going to use the power series expansion method. Now I need to divide 1 by this particular expression, but the way in which I divide depends on the ROC. If you observe ROC, it is given as mod of z greater than 1. It means it is going to be a right-sided sequence. Mod of z greater than 1 implies a right-sided sequence. So if the sequence has to be right-sided, then I need to get the negative powers of z as the original expression. So what we do is we are going to have the numerator 1 here, that is going to be divided by 1 minus 1.5 z inverse plus 0.5 z inverse. So we actually go for the division, long division method, so as to get the answer. So the first value will be 1. So this gives me 1 times 1 is going to be 1, and minus 1.5 z inverse into plus 1 is going to be minus 1.5 z inverse. Similarly, plus 0.5 z to the power minus 2. Now I should subtract them, so I'm going to flip the sign. So plus 1 is going to be minus sign, minus sign is flipped as plus, and this plus is going to be flipped as minus sign. So 1 minus 1 is going to be 0, so I discard this. Now this value will be 1.5 z to the power minus 1 minus 0.5 z to the power minus 2. Once again I continue my journey. So this expression must be dividing 1.5, so I'm going to write this answer as plus 1.5 z inverse. So if I multiply this with 1, the answer will be 1.5 z inverse. So plus into minus is going to be minus, and then 1.5 into 1.5, that's going to be 2.25 z inverse. Next, 0.5 into 1.5 is going to get me 0.75 z raised to minus 2, z raised to minus 1, that gets me z raised to minus 3. So once again I'm going to flip the signs. So this is plus, it's going to be minus, this minus is going to be now plus, this plus is going to be minus now. So 1.5 z inverse minus 1.5 z inverse, this is going to be 0, this term gets cancelled out. Then we have minus 0.5 z raised to minus 2 plus 2.25 z raised to minus 2. So if you try to subtract it, that will be 1.75 z to the power minus 2. Now this term is anyways 0.75 z to the power minus 3. Now since 3 values are asked, I have gotten already first value and second value. I should go for the third value. Now the coefficient here is 1.75 into, z to the power minus 2. Here it is 1. So I will be able to multiply it with 1.75 z to the power minus 2. So if I multiply this with the first term, I'm going to get 1.75 z to the power minus 2, and now 1.75 into minus 1.5, so that is going to get me minus 2.625 z to the power minus 3. Next I have one more term to go, that is 1.75 into 0.5, that gets me 0.875 z to the power minus 4. So once again, you can just continue your journey by flipping the signs and so on. But now you can see here that I have gotten three terms here. So I'm going to write x of z now as x of z is equal to 1 plus 1.5 z to the power minus 1 plus 1.75 z to the power minus 2 plus dot dot dot, because it just continues. So if you look at the power of z here, it is 0. So I can very comfortably say that x of 0 is equal to 1. Next, if you look at the power of z, it is minus 1. So this should correspond to the value of n equal to 1, right? Because ROC is mod of z greater than 1. So this corresponds to a right-sided sequence. So the value of n should be 1. So this is going to be equal to the coefficient 1.5. Similarly, if you look at the third term, we have x of 2 is equal to 1.75 and so on. Since the problem asks us to find only the first three numbers, we have done so. So if I write it comprehensively, I'm going to write it as x of n is equal to dot dot dot. Then we have the value 1 here at x equal to 0. So this is the value at the origin. And then the next coefficient is 1.5. And then the next coefficient is 1.75. So that's the value of x at n equal to 2. And then it just continues. So we'll have other numbers as well, but we are not interested. We just want to have only three numbers. So this is the time domain signal corresponding to the z transform x of z, which is given over here. So this is how you can calculate the time domain signal from the given x of z using power series expansion method.